Problem 25, page 684. We have a square at the corner. At the corners of the square, we have four charges, positive charges. We can label here 1, 2, 3, 4. The question is, we have to find the electric field at the location of Q. After, we have to find the total electric force. Okay, first of all, we have to find the field. We can choose the blue color. We have to find the field at the location 1. Be careful, we are talking about the location. We don't talk about the charge Q1. The electric field is calculated with respect the location. For example, if I have a charge plus here, I want to calculate the field at the location P, for example, and this charge is Q1. So here you will have E1 is the field created by the charge Q1 at the location P, at the position P. So we don't talk about the charge which exists here. We don't talk about this. E1 equal K, the created field Q1, absolute value, divided by the distance R square. Okay? Here we have to calculate the total field at the point 1. At the point 1. First of all, let's draw all the field at the location 1. Here, 2Q, we can say the charge 2 will create at this point a field E2. So it's E2. And here we have the charge 3 will create, we can here draw a line between this point and the charge. It's positive, so the field must be out. Must be out. We can have out. It's E3. And Q4 is positive, the field must be out. We can choose a color, a different color. So here we have E4 created by Q. This is equal Q4. And we have this one E3, which is created by Q3, and here we have E2, which is created by Q2, equal to Q. Now let's illustrate the components of these vectors. We see, well, here we have only, we can choose here the x-axis. This is the y-axis, and here we have the x-axis. So here it's y-axis, and here x-axis. We have only E3, which has two components. So here we have E3x, and here we have E3y. 3y. Let's write the mathematical calculation. E3 equal the total field created at this position, I repeat, at this location, equal the summation of all these vectors, equal E4 plus E3 plus E2. It's important to write this equation. I told you many times you have to write the equation of the vector, the vectorial equation. It's important. E4 equal E4x plus E4. It's here. We don't have E4x. It has only a y component. So we can delete E4x. We have only E4y plus E3 has two components, E3x plus E3y. E2 has only x component, so plus E2. So now we can write the components, just the scalar component equal E4y, E4 in the positive direction, all are in the positive direction. So it's in the j direction, plus E3x in the I direction, plus E3y in the j direction, plus E2, it's E2x, E2x in the positive I direction. Okay, you see well, E4x equal E4, and because the sign is 90, so E4y equal E4 sine 90 equal E4 equal K Coulomb constant times Q4, it's 4K, Q4 times 4K, 4Q, excuse me, it's 4Q, the absolute value of 4Q. Anyway, it's a positive value. Divided by, okay, we can put it anyway. Divided by the distance square. The distance equal a square. The same for E3x. Okay, E3x has an angle theta here with E3. We have to find it. Here we have an angle 90, A, so it's 60. The opposite angle equal 60. Excuse me, it's 45. It's 45. So it's 45 degree. So E3x equal E3 cosine, because we took this triangle. The x component, the adjacent one, is cosine. Cosine 45 equal E3 equal K, Q3 equal 3Q over the distance equal A radical 2 equal A radical 2 square. Cosine 45 equal radical 2 over 2. It's okay, it's okay. Now E E3y. E3y equal E3. It's here. It's the opposite side of the angle. You have to calculate E3y by the sine angle equal E3 sine 45.